Hi guys, welcome back to another video tutorial. So in this tutorial we'll be going over how to find an equation of the normal using differentiation. Now if you haven't watched the previous video tutorial on how to find an equation of a tangent, what I would say is go and watch that first before doing this video tutorial or watching this one. Okay, I'll put the link on the top right hand corner for you guys to go and check that out. Okay, so let's get straight to the question. So we have a curve that has an equation y equals x cubed minus 16 over root x, and we want to find the equation of normal at 4 and 3. So this is quite similar to the previous video tutorial on finding equation of tangent. The only difference is the normal, which basically means gradient. So the way this works is when you find an equation of a tangent, say this is your line, you find the equation of the tangent, right, of that curve at this point, right? So this is your tangent. When you want to find normal, basically, okay, let me put this as tangent first. So this is your equation of tangent from the first video tutorial. When you want to find the normal, all the normal is basically 90 degrees to the tangent, right? So the normal is basically 90 degrees. And what that basically means is the gradient is going to be perpendicular for normal. So for normal, you should know that the gradient m is going to be perpendicular to the actual gradient that you find. And I'll show you that. I'll show you how to do this when we do the question. That is the only difference. That is it. Everything else is the same. The method and everything else is the same. All you have to do is once you actually find your value of the gradient, you just find the perpendicular gradient and then you put that to find the equation of the line. Okay, so let's do this and I'll show you how to do that. So the first thing is what we need to do, because we need, remember, if we want to find an equation, we need to have a gradient, right? And we need to have a coordinate, which we do have, which is 4 and 3. So the way that I'm going to find the gradient first is I'm going to differentiate this. So I can rewrite this equation first. Y equals x cubed minus, now that square root x, what does that square root x mean? So I'll write this as step 1. Square root x means x to the power half, does it not? But because I want to differentiate, yeah, so you should know square root x means x to the power half. But because I want to differentiate, I'm going to move this x to the power half to the top. And remember, if I move x to the power half to the top, this is now going to become x to the power minus half. GCSE indices, I think this is, right? So remember, whenever you move something from bottom to top, the sign changes. But because this was positive, I'm moving it to top, so it's minus. Now I'm going to differentiate. So I'm going to do dy dx. So this is going to be 3 times 1, 3, and then take away 1. So that's going to be 3x squared. Now I'm going to times this power by minus 16. So both negative, so that becomes plus. So 16 times half is 8x. Now I'm going to take away 1. So minus 1, my minus half minus 1 is minus 3 over 2. So I can rewrite this again as dy dx equals 3x squared plus 8 over, bring this x to the power minus 3 over 2 down to become positive 3 over 2. Okay? Now remember, we want to find the value of the gradient. So I know that my x coordinate is 4. So if I put 4 in here, you should be able to find the actual value of the gradient, m, right? So if you put 4 here, again, you can use your calculators for this, so you don't need to be spending too much time on working out the value for this. So your value of your gradient for this one, m, is going to be, so what's that? That's square root 4, so that's going to be 2. 2 to the power 3 is 8, so 8 divided by 8 is 1. So that's 16, 16, 3, 48, 48, so that's 49, I think, is it? Just double check that. I think that's 49. Let me just, yeah, I think that should be, so that would be square root 4, yeah, 281. That's 16, 16, 3, 40. Yeah, that should be 49, the gradient. Okay, so we have my gradient. Now, remember, because I want to find the normal, right, not the tangent, the gradient 49 now is going to be perpendicular. So the perpendicular gradient, remember, if I'm saying perpendicular, you have to flip it. So it's going to be 1 over 49, but then you add minus. So that's the perpendicular, right? So if you want to find the perpendicular gradient, remember, bring the 49 down and then add a minus. So for example, if you had 5 over 3 and you want to find the perpendicular gradient to that, it's going to be minus 3 over 5. Okay? So now what we're going to do is find the equation of the line. So I'm going to use y minus y1 equals mx minus x1. You know your value of your gradient, and you also have your coordinate 4 and 3. So you're going to sub it in. So this is going to be x1, this is going to be y1. So y minus my y1, which is 3. My gradient now is going to be minus 1 over 49, bracket x minus 4, because that's your x1. So keep y minus 3 here, expand the bracket, minus 1 over 49x. That's going to be plus 4 over 49. Now, if you bring minus 3 to the other side, what would that become? That would become plus 3. Okay, so if you add that, you can use your calculator, by the way, to solve this, so you don't have to do this mentally. Your final answer then would be minus 1 over, so y equals minus 1 over 49x, and if you bring 3 to the other side and you add that, that's going to give you 151 over 49. And that is how you find the equation of a normal. Okay, so remember, the steps are exactly the same as the previous video tutorial on finding the equation of tangent. Differentiate it, okay, and then put your x value to find your gradient. But remember, this is the key point here for this point. So this bit here is the key, where you have to change the gradient. Make sure that it's perpendicular gradient. Okay, this is where you'll lose the marks. So you make sure you find the perpendicular gradient, and then once you got the perpendicular gradient and you got your coordinate, you just put it back into the equation of the line formula to find your final equation for the normal. And that's pretty much it. So if this video has helped you to understand how to find or how to solve this kind of question, please give this video a big thumbs up. And if there are any doubts or questions questions regarding the method, just put it down in the comments and I will get back to you. So until the next one, I shall see you, I guess. Yeah, I shall see you for the next video.